In this question, we have to explain qualitatively why the total mechanical energy is going to be conserved for the system. This is part B of the first question, right? The part A you can find here in the link. Now we'll discuss that why the total mechanical energy. The application of this part we have done in the second part of part A. Okay, you can find the link, of course. The reason why the total mechanical energy is going to be conserved for the system, because there is no non-conservative forces like friction, viscosity, drag forces. These are non-conservative forces. So very briefly, I'll tell, like suppose there is friction acting between a block and the surface. There is some friction force present. So whatever, if this block moves ahead by some distance d, then the work done by the friction force is the friction force, the magnitude of the friction force times the displacement. So this work done by the friction force is going to be lost from the system in the form of heat, sound, light, and these things. So these things we can observe and relate to our day-to-day life. So such forces are not present. The question is saying that the friction forces are negligible or absent here. That's why there is no loss of energy. That is one thing. And on the system, this M1, M2 and Earth system, there is no external force. Whatever are the forces are from within, right? The Earth is applying force on M1 and M2, right? So there is no external force on the system. That's why there is not going to be any change of total mechanical energy. Suppose these are two bodies, okay? So when they are this far, let's say distance d1, right? And let's say they move a bit closer. They move a bit closer. Whatever are the forces, the force between the two, they are applying on each other. So for on this two body system, there is no force from outside, right? So maybe here, this is case number 1 and this is case number 2 when the bodies have moved closer. So the movement has been due to the forces between them. So here, the sum of the total potential energy and the total kinetic energy, whatever it was here, is going to be the same. When they have moved closer, the total potential energy magnitude wise has increased, but because potential energy is attractive force, so it's negative. So magnitude wise here the potential energy more, but per se it is lesser. But still the idea is Ke plus Pe here is going to be the same as Ke plus Pe here. When they will move closer, they will now have some kinetic energies. If they were not moving initially, when they have moved closer, they will now have kinetic energy. The potential energy has decreased, not in magnitude, but because there is a negative sign. So yes, so it has decreased. So that decrease in potential energy went on and became kinetic energy. So this is the case, okay? So this is like, very broad scale Earth and the mass, but that is what is happening there in that case also. So there is no external force on the system and there is absence of any forces that, that may cause some loss of energy. So hence the total mechanical energy is conserved, so it does not change. This option here becomes the answer for this question. Okay, thank you.